Okay, we're going to do the Chapter 12 review. It's found on page 385. Number 1, define the following terms. A, oxidation state. The oxidation state is the state on an ion or in a molecule. It's the charge the atom would develop if the more electronegative took the electrons. So in other words, it's the charge it would develop if it was ionic. But let's use what he says. So it's the charge on an ion or in a molecule that it would take on if the more electronegative took the electrons. Something about that. B, galvanic cell. It's a system that uses a redox reaction to produce electrical energy. An anode is the negative electrode in a battery or a galvanic cell, and the cathode is the positive electrode in a battery or a galvanic cell. Electroplating is when you use reduction to coat an object with a metal, and corrosion is the chemical deterioration of substance, usually by oxidation. Number 2, using the definition of oxidation, not the rules we developed. What is the oxidation state of each atom in IBR? If you look at your periodic chart, you see that the I is lower on the chart and BR is higher on the chart, and the electronegativity increases this way and this way. Okay, so the electronegativity increases this way across the chart, which means the Br, the bromine, would be the more electronegative of the two. And remember, if you had bromine, and each of these are in group 7, right? There. And then iodine, 1, 2, 3, 4, 5, 6, 7. Okay. This guy's going to steal the electron. So this guy is going to steal the electron and become negatively charged. This guy's going to lose it. He's going to be positively charged. And it's because this one is higher. Remember, the electronegativity across the chart increases this way and this way. And the iodine was here and the bromine was here. And therefore, this one gets the electron. So the answer to that would be that this would be the negative one and this would be the positive one because of the rules. Excuse me, not the rules, because of the definition that the more electronegative would grab the electron. Number 3, using the rules you learned in this chapter, which remember the rules are back on page 360, give the oxidation state for each of the following substances. Let's do this one first. The first rule says for ions composed of only one atom, the oxidation state is equal to the charge of that ion. Well, here, this is a group 1 metal, so it's going to make a +1 ion. Okay, then if you keep working through the rules, number 2 is for all elements of homonuclear molecules, the oxidation state of each atom is 0. Number 3, the molecules in polyatomic ions, the sum of the oxidation states must equal the total charge. Okay, which this is the total charge is 0. Number 4, the oxidation state of fluorine is -1, and that's not here. Number 5 is that hydrogen is +1. That's not here. Then it says oxygen is a -2. So what do we have here? We have +1 plus whatever manganese is going to be plus 4 times -2. And that whole thing has to equal 0. Excuse me, 4 times -2. I can write, I said it right, but I didn't write it correctly. So this is -8 plus 1 would be, and to make this true, with -8 here and you have a +1 here, manganese would have to be +7, wouldn't it? Otherwise this wouldn't work. So this has to be +7. I'm going to get rid of that. To this one, this is not a group 1 or group 2 metal, but this one we said was rule number 4. It's going to get a -1. It's got a 0 charge, so it's going to be -1 times 2, which is the subscript, plus whatever the selenium is. So this has to be a +2 to make that equal to 0. It said on rule number 2, for all elements in homonuclear diatomics, the oxidation state is 0, so that's going to be a 0. Over here, we don't have an ion. There's no metals here. And so then we have to skip. And number 2, there's no elements or homonuclear diatomics. The overall charge is going to be 0 on this. We get to number 4, there's no fluorine in here. We get to number 5, there is a hydrogen. There's 3 of them, so we got a +1 here. So we have 3 times +1. So far, this whole thing is going to equal 0. Okay. We don't have an oxygen, and so we get to number 7, and it says especially chlorine is a -1. So we know this is plus a -1. So now we can figure out carbon. We have +3 minus 1 is +2, so carbon has to be +2. Now let's check it. That would be, no, that's not right. So to make this true, carbon would have to be -2 because we have +3, so we need a -3 to get to our 0. So that would make our statement true. So carbon would have to be -2. Let's do this one. Okay. This one is a group 2 metal, so it's going to get a +2 charge. The second rule doesn't apply. The third rule, the molecules in a polyatomic ion, the sum of the oxidation states must equal the total charge. And so we know that, but this is already worked in here. The next rule that's going to apply is oxygen, which is a -2. So we have 3 times +2 plus 2 times whatever phosphorus is, plus 2 times 4 is 8 times the -2, because there's 2 times 4 of those, there's 8 of those at -2, and that whole thing is going to equal 0. So this is -16, this is +6 plus 2 times phosphorus, and we need to make that statement true. So this is going to be -10, and so if you had 2p equals 10, because we're going to flip that to the other side, aren't we? P has to equal 5. So we put this up here, and P is going to equal 5. Plus 5, I guess I should say, plus 5. Okay. And that's why. Boy, what a mess, huh? Okay. Let's do this one. That was a 3. This one, the rule, it gets to the fluorine rule first, so it's going to be a -1 here, so this is going to have to be a +3, which is really interesting. But this one is what number rule? The 4th rule. So you have to give it the -1. And remember, it's because the electronegativity increases across the chart this way, and fluorine is the top guy on group 7, so that's why he's going to get the -1, and everybody else is going to have to give it up when it comes to him, because he's going to grab the electrons and get the -1 charge. Okay, let's do the last 2 here. P4 is rule number 2. That is a homonuclear molecule, so it would get a 0. Excuse me, and then this one, there's no ions here, and there's no fluorine, so you'd go down to rule number 5, which means this is going to get a +1, and there's 4 of these, so this is going to have to be -4. And so, oh, shame on me. No, let's do this one again. Do this one again. Okay, if we work our rules, rule number 3 says whatever the polyatomic ion's charge is, that's going to be what the sum equals. So in this case, I'm going to put it above here. If the whole thing has to equal 1. Then the next, we missed the fluorine rule, but then we get to hydrogen. This is +1. So we have +4, and we need nitrogen +4 equals 1. So nitrogen has to be a -3, doesn't it, to make this true? And the reason it's 1 is because there is a charge there. That's a polyatomic ion. So nitrogen's going to have to be a -3. It's not hard, but like everything in chemistry, you got to know what you're doing. Number 4, for each of the following reactions, indicate whether or not it's a redox reaction. If it is, indicate the atom being oxidized and the atom being reduced. Also indicate the oxidizing agent and the reducing agent. Okay, so for the first one, we have Cl2 yields 2 HCl. plus Br2. Okay, let's work our rules. Homonuclear diatomics get a 0, so I get a 0 and a 0. Let's do this one. This one is a group 1 metal. The first rule tells us it gets a +1, so this guy has to get a -1. What do we see already? We see that bromide went from a -1 to bromine, which is a 0, and that means this is being oxidized, isn't it? So we know right away bromine is being oxidized. And let's look at chlorine. Over here, this is a +1, this is a -1. So this went from 0 to -1, so we know Cl is being reduced, don't we? So we know this is a redox reaction, and because chlorine is being reduced, it's the oxidizing agent. Because chlorine is being reduced, it's taking electrons, so it is the oxidizing agent. And this guy is giving the electrons, so that is the reducing agent. Okay, so that was the information you were supposed to put on that one. Let's do the next one. We have 2N. Okay, let's start figuring out if this is even a redox reaction. So we're going to start over here. We don't have, rule 1, we don't have any ions. So no group 1, group 2 metals here. Rule 2, no homonuclear diatomics or things by themselves in their elemental form. Rule 3, this is the overall sum will have to be 0 here. Rule 4, there is no fluorine here. Rule 5, hydrogen. This gets a +1. Okay, and then this one is going to get a -2. That's the next rule. So what do we have here? We have +1 plus whatever nitrogen is, and 3 times -2, which is -6, and the whole has to equal 0. So nitrogen has to be +5. Okay, got that one done. Now we go over here. This is going to be a -1. This is going to be, excuse me, this is going to be a +1. I can do this. This is going to be a -1. Okay. Then we get over here. Well, we know this guy's 0, don't we? Because of the rule about elements or homonuclear diatomics. That's going to be a 0. And so right away we can look at this and we can go, this one went from -1 to 0. And here, let's just look at this real quickly. This is going to get a -2, so this is going to be a +2. So over here, nitrogen went from +5 to +3. What do we see here? We see that iodine went from -1 to 0, so it is being oxidized. So we know iodine is being oxidized. And we see that nitrogen went from +5 to +2, so we know nitrogen is being reduced. Okay, and so we know that this guy is receiving the electrons, and therefore it is the oxidizing agent. And this guy is actually giving the electrons, and therefore it is the reducing agent. Okay, so we did everything we were supposed to on that one. And it definitely was a redox. The next one, if you actually go through and do the numbers on there, you'll find that it is not a redox reaction because, and I'm going to leave that to you, they don't change. The oxidation numbers stay the same from the reactant side to the product side. Okay, let's do D. We have 2 potassiums. Now I know right away this is going to get a 0 and this is going to get a 0. Those are the easy ones, aren't they? I know that this one's going to get a +1 and this one's going to get a -2. I know that this one's going to get a +1, this one's going to get a +1, and this one's going to get a -2. Let's see. Hydrogen went from a +1 to a 0, so hydrogen is being reduced, isn't it? Okay, and if hydrogen's being reduced from water, then water is my oxidizing agent. Now, potassium went from 0 to +1, so potassium is being oxidized, and that means potassium is our reducing agent. Okay. Let's go to the next one. Did I do that right? Yes. Okay, good. Now let's start. We know this one gets a 0 because it's self-standing. It's by itself. So let's go ahead and look at this. V is not a group 1 or a group 2 metal. It's actually a transition metal. So the first rule that's going to apply here is -2. So we got a -6 here. The whole thing is going to equal 0. And we have 2 times whatever V is. So what does V have to be? Well, this whole thing has to be a +6, and there's 2 of them, so V has to be a +3. Okay. And then when we come over here, let's do these guys. This is, this is -2. And there's 6, -6, the whole thing has to equal 0. There's 2 of these, so whatever FE is, it's got to be a +3 to give you a +6 so that that all cancels out. Okay, and then over here, this is a -2, so this is a +2. Now, let's look at it. Iron went from 0 to +3, so iron is being oxidized, and so it is the reducing agent. The iron is the reducing agent. Okay. Then the oxygen remains the same, but V, which I'm pretty sure is palladium. Oh, vanadium. V is vanadium. Whoa, that's a heck of a name, huh? V went from +3 to +2, so vanadium is actually being reduced, and so V2O3 is the oxidizing agent because it's the one that's being reduced. And so we've got all the information we were supposed to do there. Number 5, fill in the blank. Batteries are based on blank cells, galvanic cells. Number 6, what does the salt bridge do in a galvanic cell? It keeps both sides of the galvanic cell neutral. Remember, otherwise they would eventually run out. And so it keeps them neutral so that the reaction can continue to go. Number 7, one side of the galvanic cell has Fe3 becoming Fe solid. And notice that it is being reduced because it went from Fe +3 to Fe, which has a 0 oxidation number. A, is this the anode or cathode of the cell? Now, I'm going to show you at least this part. We're going from Fe to this, which is a 0. This one is a +3, okay? So this has to be, it's being reduced. It's receiving electrons. And to be receiving electrons, it has to be the positive side because that's why the electrons would be attracted to it. So it's going to be the cathode. So the answer to A is the cathode. B, the electrons flow towards the electrode or away from it on this side. The electrons flow towards the cathode. They flow towards the positive. And then C is the salt bridge. In the salt bridge are positive or negative ions flowing towards this side of the cell. The positive ions are flowing to this side of the cell to keep the cathode side positive so that the reaction will continue. Number 8, the reactions that run 2 galvanic cells are given below. Draw the cell identifying the anode, cathode, the electron flow, and the substances on each side of the cell. You definitely are going to see something like that on your test. Okay, so I personally go ahead and I set up my little thing. I have my salt bridge between the two. I have my electrons always flowing in the same direction. Therefore, there's my electron flow. Therefore, I know which way it's going. If the electrons are going this way, I know this is the cathode. I know this is the anode. So I can go ahead and set up both of mine like that right away. Ooh, it's pretty ugly, but you get the drift. These are the electrons. Okay, that's my cathode, that's my anode. Let's do the first one. The first one, we start with lead. I'm going to write this down here so you can see it. We have a lead solid plus silver, and that's in an aqueous solution, and that yields aqueous plus 2 silver solid. Now let's look. This has a +1, this has a 0, this has a +2, this has a 0. The silver is being reduced, so it is receiving the electrons. So the silver has to be, the aqueous silver has to be over here. I can do aqueous, there we go. The aqueous silver has to be over here. And that means the lead, notice it's being oxidized. So this electrode over here has to be lead. And that's this one. I'll put electrode, okay? I have arrows going both ways, and they should be going that way. I'm so sorry. There we go. Okay. And so then what's on this side is we have the silver aqueous over here, and the silver solid would be the electrode over here. Did he ask for that? He says identify the anode, the cathode, the electron flow, and the substances on each side. So actually you didn't have to do that. If you put that the silver aqueous is here and that the lead electrode is over there. This is your solid because that's your electrode. I think we're good. Okay, so that's enough. That's what you can do there. Okay, let's do the next one, which is, we're going to use this one. And hopefully my little electrons are going in the right direction this time. Okay, this one, we have chlorine, homonuclear diatomic, it's aqueous, plus this is aqueous, and that's going to yield 2 Cl minus aqueous plus 2H plus aqueous. Now, this goes from 0 to +1. This one goes from 0 to -1. Okay, so chlorine is being reduced. So it's going to be on the receiving the electrons end. So I'm going to put my chlorine over here because it's going from 0 to -1. It's being reduced. It's receiving electrons. That means over here must be, the H2 aqueous. Okay, oh, and we have an electrode here and an electrode here. Okay, but I think that's what you needed to say, was that the hydrogen is in the solution over here and the chlorine is in the solution over here. And show your electrodes. Show that this is the cathode, this is the anode, and that the electron flow is in this direction. Here's your salt bridge. Did it say the salt bridge? Nope, you didn't have to draw the salt bridge. Didn't say that. I'm just used to doing it. Okay. Number 9. Oh, balance the following redox reactions. There's stuff like this on your test. And so we have I negative aqueous plus Ag positive yields I2 plus Ag. I left out the phase symbols. Please forgive me. Now, if you look at the oxidation numbers, this one is -1, this one is 0. This one is +1, this one is 0. What does that mean? Well, there's 2 of these. So for this to go from -1 to 0, you're going to need 2. It's going to have to receive 2 electrons. Where's it going to get the 2 electrons from? From this guy. This guy gives the electrons. See? It gives the electrons. But you're going to need 2 of them. So you're going to have to put a 2 here, and we have to have 2 of these just to balance the equation. And so you're going to have a 2 here also, aren't you? Okay, so now you have 2 of these, 2 of these, and 2 of these, and 2 of these. But look at your electrons. We have 2 iodines, and they're going from -1 to 0, which means they're giving an electron. So there's 2 electrons being given. So you need 2 silvers, because the silver, each one receives 1 electron. It goes from +1 to 0. So you need 2 of them to receive those 2 electrons, and therefore this would be balanced. Okay, you're following the electrons. That's what you're doing. Let's try this again. Okay, barium plus gold yields barium iodine, barium ion plus gold. Okay, once again, I left out the phase symbols. Please forgive me. This is going to have a 0 oxidation and a +3 over here. What does that mean? That means gold is receiving 3 electrons. So it's got to be getting those electrons from here. And this is 0 to +2. This is losing 2 electrons. Now we know when we've got this guy receiving 3 and this guy losing 2, that the lowest common multiple is going to be 6. And so this guy is going to get the 3s, and this guy is going to get the 2s. So now we have 3 of these, and each one is giving 2 electrons, so that gives 6 electrons to be given away. And each of these receives 3 electrons, and there's 2 of them, so that'll take care of those 6 electrons. And so that's how we balance that. So we're actually looking at the electrons and balancing it for the electrons, but it still has to be balanced. You know, you notice that it's still balanced as far as the atoms or ions. Okay. Number 10. A student says that since the battery he is using is a dry cell, it contains no water. Is the student correct? No. Why or why not? Dry cells have aqueous ions in the salt bridge, and one actually produces water. So he's not correct. Number 11, in a zinc carbon battery, is the carbon the anode or the cathode? The zinc carbon battery, the carbon actually receives the electrons, therefore it's the cathode. Number 12, which battery was first to be developed, the zinc carbon battery or the alkaline battery? The zinc carbon battery. I bet you never thought you were going to know much about batteries, did you? Number 13, which of the 2 batteries mentioned above can be recharged? The alkaline battery is the one that can be recharged. Number 14, which of the 2 batteries mentioned in number 12 has components of the salt bridge that actually take part in the reaction that runs the battery? That would be the zinc carbon battery. Number 15, what causes a battery to die? When at least one of the reactants runs out. That's when a battery dies. Number 16, which battery or batteries that you learned about in this chapter have a pH less than 7 on the inside? And that would be the zinc carbon battery and the lead acid batteries. Number 17, when a metal is electroplated onto an object, should the object be attached to the anode or the cathode of the battery? It needs to be attached to the anode. And number 18, you have some gold metal that you would like to electroplate onto an object. What would you do to make a solution you could use in the electroplating process, you would add a strong acid. And if you did that, that would actually help in the electroplating process. Okay, if you can do all these and answer all these questions without looking at the chapter, then you're probably ready to take your test. So go ahead and study for that and take test 12. I'll see you soon.